How to find the inverse of any function. For example, y equals to 4 over x plus 9. To start, you have to replace y and x, so this becomes x equals to 4 over y plus 9. What we're trying to accomplish here is put y by itself, so we can tell what the inverse is. So multiplying each side by y leads to xy equals to 4 plus 9y. Then you subtract 9y on both sides, so this becomes xy minus 9y equals to 4. Factor y out, this becomes x minus 9 equals to 4. And then you divide each side by x minus 9, so you get y equals to 4 over x minus 9. This should be your answer. However, we need to prove this. To prove it, should have learned this in class, but to prove it, the inverse function of the function must equal to x. Conversely, the function of the inverse function must also equal to x. So let's prove that. Let's do the first example. Inverse function of the function. So what is our original function? It's 4 over x plus 9. So we can just replace that with 4 over x plus 9. What we do here for the inverse function, if you've learned composition of functions, is that you replace whatever x here, and you put whatever is in here into here. So let me explain. This equals to 4 over, you put here this value into this x. So this becomes 4 over x plus 9 minus 9, because we use this function. If we use algebra again, or just simple math, we get 4 over x. The 9's cancel out pretty much. And 4 over x is pretty much 4 times x over 4. The 4's cancel and you are left with x. So this works. Now we must prove if the function of the inverse function works. So our inverse function is this. Let's plug that in. So f of -1 of x equals to f of, this is our inverse function, so we can just plug that in. So we have that. Our original function is 4 over x plus 9, so let's go with 4 over x minus 9 plus 9. What this leads to is, because the 4's will cancel out, it's 4 times x minus 9 divided by 4, so you get x minus 9. 4 over 4 is 1, so you just have x minus 9. So x minus 9 plus 9 will become x. So the function of the inverse function also works. So we can say that the inverse function of y equals to 4 over x plus 9 exists. And that is this value, y equals to 4 over x minus 9. Okay, let's do another example. This time, we're going to do y equals to the cube root of x. To first find the inverse, we replace x and y as we did in the last example, so this becomes this. If you cube both sides, then you're left with x cubed equals y. So this should be our inverse. We need to prove it, like we did in the last example though. So first, let's break this up into two parts. This must equal to x. The inverse of the function must equal to x. And the function of the inverse of x must also equal to x. So let's start with this one first. So the inverse of f of x, which is originally cube root of x, is basically you put this into x here, so this becomes the cube root of x cubed. Because you're already doing a cube root and then you cube it, then pretty much the cubes cancel. So this becomes x. Okay, so this one works. How about this one? The inverse function we already proved is x cubed, so we can do this. And since our function is the cube root of x, then we can just put x cubed into the cube root of x, so this will equal to, and pretty much like the last example, the 3's will cancel out, so you're just left with x.